Hello and welcome, and thank you for watching this video on triangle inequalities. In this video, I'm going to explain the triangle inequality theorem and show you how to use it to determine if three segments can be attached together at the corners, at the endpoints, to create a triangle. Because there are some conditions and some possibilities that segments cannot be connected at the endpoint. Some segments, a combination of some segments, cannot be connected at the endpoints to create a triangle because the segments will be too short to attach again to create a triangle. So let's start off with the triangle inequality. So if we begin by the definition, going over the definition of triangle inequality, the triangle inequality states that this triangle inequality theorem states that if I get the sum of any two sides, if I add up any two sides on a triangle of the segments, they have to be greater than the measurement of the third side. So for example, if I add 7 with any of these numbers, that's obviously going to be bigger than the other numbers. Like if I add 7 and 6, that's obviously going to be bigger than 3. If I add 7 and 3, that's obviously going to be bigger than 6. But the key thing that I want to look at is, okay, what happens when I add the two smaller ones? Now, the triangle inequality has to satisfy, again, all three sets. It's obviously going to satisfy the sets when I start off with the bigger number and I add, again, any of the two smaller values, because that's automatically going to be, it's going to again satisfy this condition that adding, in this case, 7 with 6 is going to be bigger than 3. Adding 7 and 3 is obviously going to be bigger than 6. But the key thing is, okay, what happens when I add the two smaller numbers? Will adding the two smaller numbers be a value that is bigger than the length of this biggest number, which in this case is 7? And the answer in this situation is yes. It is going to be bigger than 7. So in this situation, if I have three segments that measure 3, 6, and 7 units, I can attach them at the vertices, at the corners, which end up being the vertices of the triangle, and I can create a triangle. Now, it's any triangle, not a specific type of triangle. It's not going to be a right triangle necessarily, or an isosceles. Well, in this case, it is obviously going to be a scalene triangle. Okay, not an isosceles triangle, but in terms of the angle measurements inside here, this looks like it's an acute triangle. But again, we're not going to create a specific type of triangle. We're just going to create a triangle, all right, for sure. So let's look at some examples of this. So if we look at these examples here, obviously, again, if I add 24 with 17 or 24 and 8 is going to be bigger. That sum will be bigger than the other value. So 24 plus 17 is going to be bigger than 8. 24 and 8 is going to be bigger than 17, because again, 24 is already bigger than both of those numbers. But the key thing I want to look at, okay, is what happens when I add the two smaller ones, when I add 8 and 17. Well, 8 plus 17, that's equal to a total of 25. And well, 25 is greater than 24. So in this case here, these three segment links, if I get a segment of 8 units, 17 units, and 24 units and connect them at the endpoints, they can create a triangle. So this would be, yes, I am going to create a triangle. Let's look at the next example. Like I stated again, if I start with 35, 35 is the biggest number. 35 plus 12 is automatically going to be bigger than that. 35 plus the 25 will be bigger than 12. But the one that I really need to make sure gets satisfied, again, satisfies this theorem and satisfies the rule, is when I add, again, the smaller of the two numbers. If I add the two smaller segments, will it be bigger than the length of the largest segment? So let's see. If I add 25, let's do it over here. If I add 25 and 12, well, that's equal to 37. And 37 is greater than 35. So this would be, again, another yes. Yes, this would create a triangle. So let's look at the next example. The next example, again, Obviously with 50, like I mentioned before, with 50, that's going to automatically work. 50 plus 28, 50 plus 22, okay? That satisfies the first two cases, the first two sets, but the set that I'm really interested in is when I add the two smaller, the set that adds the two smaller numbers. Well, let's see. If I add 28 with 22, that is equal to exactly 40, 50. That's equal to 50, and 50 is not greater than 50, okay? 50 is equal to 50. The Triangle Inequality Theorem states that adding the two smaller sides, okay, or adding the two of the sides has to be greater than, not equal to, but greater than the third side. So in this case, if I add these two sides here, I get exactly 50 and not greater than 50. So since it is not greater, then the answer to this would be no. This would not create a triangle. And let's look at the last example. Again, just to re-emphasize, since this is the last example here, if I add 24 and 12, 24 plus 12, that's obviously going to be bigger than 11. If I add 24 and 11, that's obviously going to be bigger than 12. So I have two of the three sets are satisfied. The set, again, that I'm most concerned though with is going to be when I add the two smaller numbers. If I add 12 with 11, which is equal to 23, 23 is not bigger than 24. 23 is smaller than 24, so yet again, this will not create a right triangle. Because again, like I mentioned, and I hope this makes sense, obviously 24, starting off with the biggest number, doesn't matter what I add it up with, it's going to obviously be bigger than the other number I'm not adding it up with. 24 and 12 is obviously going to be bigger than 11. So here, and along with all the other cases, the set that I'm really interested in figuring out and determining if I'm going to have a triangle or not is when I add again the two smaller numbers. Now I know again the theorem states that adding any two sides, but it's really the two smaller sides. If I add the two smaller sides, will the sum of the two smaller sides be greater than the larger side? And in the first two examples, the answer is yes, but in the last two examples, the answer is no. Adding the two smaller sides does not equal to a number greater than the third side, the larger side. So here we have two examples where we will not create a triangle. And just so you get a visualization of what's actually going on here, what's going on here is that I have this long segment of 24 units, and I have this other segment that only measures 12, and this other segment that only measures 11. So because this is too long, this is 24, this is too long, it cannot again attach these two segments together at these corners here in order to create the triangle. Okay, so let's look at the next slide. So again, pause the video and then try to determine if these is going to create if any of these four create triangles. Well, now that you've unpaused it, let's check and see how many of these you got correct. So the first one, the answer is going to be no, because if I add 3 plus 3, which is equal to 6, 6 is not going to be greater than 7. So the answer to that is no. The answer to the second one is yes, because if I add the two smaller numbers, again 37, 42, this is equal to a total of 79, and 79 is definitely bigger than 52, so the answer is yes there. The answer to number 6 is also yes, because 14 plus 6 is equal to 20, and that's going to be greater than the 18. And the answer to the last one is going to be no, because 35 plus 7 is equal to, oh no, I'm sorry, that's a yes. That's 42, and 42 is greater than 41. So yes. So here, only the first one did not create a triangle. All the other ones can create a triangle. Now, we can use the idea again that the sum of the two smaller again angles, sides, not angle sides, has to be greater again than the length of the larger value, because again, the larger one obviously satisfy again the rule, but adding the two smaller ones doesn't always satisfy the rule. So here we can use again this idea excuse me, we can use this idea to determine the range of possibly what could be the third side on a triangle using a form of inequalities. So here on number 9, we're looking at, okay, we have a segment of 14 units and a segment of 22 units. How big or how small and how big does the third side have to be in order for all three numbers again to satisfy the condition again to create a triangle? Well, the way I do this is by simply adding these two numbers and subtracting them. So if I add, let's start with subtracting. If I subtract 22 minus 14, which is equal to a total of 8, then 8 would be the smallest length, okay? Well, that could possibly create a right triangle. Create a triangle. So we cannot go anywhere smaller than 8. Everything has to be bigger than 8. Okay, it can equal to 8. It has to be again smaller, bigger. 8 would be the smallest possible value we can get to, and I'm saying it wrong because actually it has to be a little bit bigger than that. But it cannot be. It has to be bigger than 8. Let me say it that way instead. It has to be bigger than 8. And to figure out how small or what number set has to be smaller than, okay, we do now is just simply add the two values. If I get 22 and I add 14, that's going to equal to a total of 36. So the length of the third side has to be smaller than 36, okay? It cannot be anywhere bigger than or equal to 36. It has to be strictly smaller than 36. So the third side here, if the two sides measure 14 and 22, the third side could be anything between 8 to 36. And the way we're going to express this is by using this inequality, stating that the range of our third side can be anything between 8 and 36. Not including, again, 8, not including 36, but between that. It could be 9, 10, 11, all the way up to 35, or even decimal values, okay, fractions of that, like 35.1 or 35.5. And the same thing with 8. It could be 8.1, 8.2. But it has to be bigger than 8 and smaller than 36. So for number 11 and 13, it'll be the exact same idea. To determine the range of what the third side could be in order to create a triangle, I would first subtract the two values, 11 minus 3, which is equal again to 8. So the third side would have to be bigger than 8. Okay, it cannot be less than or equal to 8. It has to be bigger than 8, and it would have to be less than 11 plus 3, which is equal to 14. So the third side could be anything bigger than 8 but smaller than 14, between 8 and 14. And the same thing for 13. 24 minus 7, that's equal to 14. And if I add 24 and 7, that's equal to 31. So that would be the range of the third side. And any number that I pick between those values, again, will satisfy the triangle inequality theorem, where adding any of the two sides will always be bigger than the third side. Especially adding the two smaller sides. Adding the two smaller sides will always be bigger than the larger number, which again is the one that we are always worried about, because adding the larger number automatically will satisfy the triangle inequality theorem. So let's see, pause the video and let's see if you could determine the range for the third side to create a triangle if the link segments are the following, for examples 10, 12, and 14. So now that you've again unpaused it and want to see it, check again whether you got these right, let's see. So if I subtract 31 and 28, well, that's equal to 3. So the third side would have to be bigger than 3 and smaller than 59. So it's a big range of numbers. For number 12, subtracting 45 and 19, that would be a total of 26. And adding that's going to equal to a total of 64. And for number 19, that would be 9 and 25. So that's your ranges for each example, the range of the third side. Now we can use this idea again to check all the possible links of the third side. So right here, we're finding possible links of a third side of the triangle using this concept. So if two sides on a triangle are 15 feet and 27 feet, what could possibly be the length of the third side? And we'll see again, because it's a range, there'll possibly be multiple answers. So let's determine what the range of this thing is. Well, we can figure out what the smallest value can be, or the what it has to be greater than, by subtracting 27 and 15. If I subtract 27 minus 15, here we go, 27 minus 15, that's going to equal to 12. So the third side would have to be numbers that are bigger than 12. So this one is definitely out because it can't equal to 12. So everything else could possibly it. 34, 29, 18, and 43 all work. But they have to be smaller than the sum of these two things. So 27 plus 15, that's equal to 42. There we go, 42. So 43 will be out because 43 is bigger than that. So these three would be a possible possible links of the third side. And again, look, we can check it out. If I add, so let's say it's this. Let's say it's 15 feet, 34 feet, and the 27 feet. Well, adding 15 and 27, we know that's 42, and 42 is bigger than 34. 34 automatically is the biggest side, so 34 plus 15 is going to be bigger than 27, and 34 plus 27 is going to be bigger than 15. So yeah, that works out. And the same thing is going to be true with 29 and 18. So there you go. So let's see, you try this example, pause it again, see if you could determine what could be, to check off all the possible links of the third side, and we'll come back right now and check it. So let's see, let's check your work now that you've again unpaused it, and let's check your work. Let's see, we have 45 and I subtract 9, that's equal to a total of 36. So that's the least possible value. It could be, again, all the possible answers have to be values that are going to be greater than 36. So 35 is out. Now if I add 45 and 9, that's equal to a total of 54. So all my links have to be smaller than 54. So 58 is out and 54 is out. So the only two that are going to be between 36 and 54 are 47 and, let me highlight it this instead. It's going to be 47 and 39. So there you go. Now the other thing I want to discuss again in this video is ordering angles and the relationship between the length of the segments, again the three sides, the length of the three sides on the triangle, and how they're related again to the angles on the opposite side. Now the smallest angle on this triangle right here is always going to be found on the opposite side to the smallest side. So like on this example, since 7 is the smallest of the three sides, that means that angle A is going to be the smallest of all the three angles. And the largest angle is always on the opposite side of the largest side. So since the largest side is this side here from A to C, then that would mean that angle B would have to be the biggest of the three angles. So in this situation, in order to order the angles, the order of these angles from least to greatest would be the following. Angle A would be the smallest, angle C again would be in the middle, and the largest of the three angles would be angle B. Now if this is true about angles, then the same is true about the sides. That the shortest side is always going to be on the opposite side of the shortest angle, and the longest side is always going to be on the opposite of the longest angle. So let's see. Oh, we're missing an angle right here, so let's figure that out. So using the triangle sum theorem, we know that adding these three angles here has to equal to 180. So if I get 180 and subtract the two angles here, which is a total of 145, I get that this angle measurement is 35 degrees. So since angle F is the shortest of these angles, then it means that the opposite side, which is ED, would have to be the shortest. And the largest angle is angle D, means that the opposite of that angle, which is angle side EF, side not angle but side EF, would have to be the longest. So if I order these from least to greatest, again the order of these three sides from least to greatest would be the following. The shortest side would be the side ED, the second would be side DF, and the longest of the three segments, so the three sides of the triangle, would be the side from point E to point F, from vertex E to vertex F. So let's see, let's do some more examples of this. So here again we want to order the angles from least to greatest. So we have here the three angles are angle F, N, and angle P. Well, the shortest angle will be on the opposite side of the shortest side. Since the shortest side is 17, angle M is going to be the shortest angle, again the smallest angle. Since the longest side is 24, from N to P, the opposites to that is this angle right here, angle N. So angle N is going to be the largest angle. And thus that means that the angle in the middle is going to be angle P. And number 2 will done the exact same way. The shortest side is 30. 30 is the shortest side. So the opposite to 30 is T. So angle T would be the least or the smallest angle. The longest angle would be S. Since S is opposite to this side here, and this side is the longest side at 38, then that means that angle R will come in second and angle S will come in third. And let's see, try this one. Now here again we're doing it from greatest to least. So alright, now that you've unpaused it, let's see if you got this correct. So from greatest to least here, for the first one, angle C would be the greatest, angle B will come in second, and angle D would be third. Again, from greatest to least. On the example 4, from greatest to least, the largest angle will be angle X. Then coming in second would be angle W. No, I'm sorry, angle Y. Okay, because 26 is smaller, so this would be the smallest angle. This would be the largest angle. So angle Y will come in second, and angle, like I said, angle W will come in third. Now the same thing is going to be true again with the sides. So moving on to the next slide. Here we want to list the sides from least to greatest. So since these two angles again are 31 and 51, just to be accurate, we can figure out the last one again by using the triangle sum theorem. So 180 minus the 57 and the 31, which is the same thing as subtracting a total of 88, we end up with a total of 92. So that's 92 degrees. Now, since 37 is the smallest of the three angles, that means on the opposite of that, which is KL, that's going to be the smallest of the three sides. And since 92 is the biggest, that means opposite of that, which is JL, is going to be the largest. So putting these in order from least to greatest, the smallest side is going to be from KL, the vertex KL. Then we'll have JK or KJ. The order of the letters don't matter. And then finally we'll have JL or LJ. Doesn't matter how you write those. And again, doesn't matter how you wrote that segment. You could write JL like I have it there, or you could write in L first and then J. It doesn't matter. It's the same segment. And then moving on to the next one, the next example again, just to be sure again that this is not going to be bigger or smaller than these two values there, we'll use the triangle sum theorem and get 180 degrees, subtract the 53, subtract the 68, which is the same thing as subtracting 121, a total of 121, which gives us a value of 59. So it actually does happen to be bigger than that. So since 53 is in fact the smallest of these two angles, of the three angles, that means that on the opposite of that, which is ST, that is going to be the shortest of the three segments, of the three sides. Now, since 68 is the longest, that means that this is going to be the longest of the three sides, which means that SV will come in second and TV will come in third. Let's see, try this one by yourself. Let's see, order these three angles, the three segments, the three sides of this one from greatest to least, and then the same thing with this one. Order this one from greatest to least. Now that you've unpaused the video, let's see if you got this right. First of all, this angle here is going to be calculated or given to us by subtracting 180 by 82 and 54, which is the same thing as subtracting a total of 13,136, which is equal to 44, which is the smallest of the three sides, the three angles. So if this is the smallest of the three angles, then that means that the opposite of that would be the smallest of the three sides. So XY will go in first. I'm sorry, that's going to actually go in last because we're doing this again from greatest to least. Almost forgot that. So starting out the biggest angle, 82, that means that this right here would be the longest. So it would be XZ would be the greatest of the three sides. Then the side from Y to Z will come in second largest, and the smallest of the three sides again is the one that's opposite of the 44, which is Y to X or XY. So from greatest to least, that would be the order of the three sides of the triangle. So on the next example, we have a 90-degree angle right here. Here we would subtract 44 and 90, which is going to be a total of 46. So this being 90 is going to be the longest of the three angles. So this being the largest of the three angles means that this side opposite to that is going to be the longest of the three sides. So if we're ordering this from greatest to least, that would be first. BE is the largest. 46 is the second largest angle, so that means that the second longest side would be BD. And since 44 is the smallest of the three angles, the opposite side of that would be third when we order this from greatest to least. So there you go. And this is how, again, you use the Triangle Inequality Theorem and how we can use the angle measurements and the side measurements themselves to determine which angle or which side is the longest or the biggest, again, respectively. Now, I hope, again, this video was helpful and easy to understand. If you haven't done so, please make sure that you follow, again, that you subscribe to the channel, and that you turn on notifications so you get updates of when I upload new videos. Again, thank you for watching, and I hope you have a great day.